Hey Year 12, I'm going to finish off exercise 12B. Last video I did 12B.1 and B.2. I'm going to do 12B.3 and 12B.4 for you here. So we're looking at how do we come up with vector equations. So with vector equations, you can basically just join them up until they form a closed polygon. Okay, now remember we've got to do from tail to tip when we line up the arrows, and then you can come up with your vector equation and it ties it all together. But in the end, you've got to, the resultant vector has to start from the starting point, end at the ending point. So for example here, in example 5, in question A, you've got vectors R, S, and T here, and it just says construct vector equations for these diagrams here. Now there's lots of different answers that would be correct, but for me, I can see here that R going that way from tail to tip, and then from that way, and then from tail to tip going this way, I can say that R plus S is going to equal to T. Yeah, so it starts from where this very beginning started, and then it ends where the last vector ends. So I would write this one as vector T is equal to vector R plus vector S. Oops, not R, S. Okay, or you can write it with R plus S first equals T. Okay, same thing. Let's have a look at question B. So question B, we've got, you can see it's sort of pointing in different directions. So either you could reverse one of them and make it the negative vector, or you could just find the ones that do naturally flow together. So I'm probably more inclined to go with naturally flows. So I can see vector P there plus vector R, yeah, is going to equal to vector Q. Yeah, so I would go vector P plus vector R equals vector Q. Another option though is you might, for example, start differently. You might say, for example, you might flip this one, for example, around this way. And you would say, well, that's minus P. Okay, minus negative vector P. The one in green there. And so you might say, for example, oh, well, negative vector P plus vector Q, yeah, green plus the yellow there, is going to give me vector R. But you can see from the first equation that I did, if you just rearrange that, right, we end up with the same equation. Yeah, if you add or subtract the same one to both sides, you get the same equation. Let's do it for this one. What have we got? So there are two pairs that kind of point away or point towards each other. 3 of them don't line up nicely, so we have to probably reverse one. So I'd probably maybe reverse this one, I think. And we could make that one negative G. Because then now I can say that plus that plus that, in the way they're already flowing, is going to equal to that one. Yeah, does that make sense? So I'm going to have negative G plus vector D plus vector E is equal to vector F. Okay, well, you can see there are different options here. You can reverse one of the other ones, so there's lots of different answers here that would be correct. Example 6, it says find in terms of R, S, and T. So RS, so vector, make sure you read the order. See how that says RS? So you have to go from R to S like that. So what could I use to express that? I would say it would have to start with going this way, right, plus that way, the pink one, yeah, the green there plus the pink. That would give me the end yellow one. So you can see I'd have to reverse my R here. Yeah. So then vector RS is going to be equal to negative vector R plus vector S. Okay. That would give me vector RS. And then let's see, this time we want SR. So if I rub that out, and this time I want S to R, so that way, okay, we have to think about, okay, which way do the vectors have to add up? So for this one, I would do, let's see, if I went from S to R, that means I would want that one to go that way, and then that one to go that way. Yeah, and then the resulting one is, it's tip to tip, tail, so the tail starts at the very beginning tail, and the tip ends with the last, the end of the last tip. So that would work that way. So I've reversed the S there, so that would be minus S. Yeah? So then this would be negative vector S plus vector R. Okay? And then vector ST, let's have a look. ST is this one. So it wants us to go this way, S to T. So which ones would we add here? Let me rub these other ones out so you don't get confused. If I want to get that one, I would have to go that one there, SO, plus that one, yeah, which would equal then the yellow one. And you can see here I've actually reversed the S, so that's negative S now. And the T still, little t still going in the same direction. So you're going to have negative S plus T. Okay, and that's going to give us ST. Alright, so pretty straightforward. It's very visual, so you're just going to practice visualizing the arrows and where you put them and how you line them up from tail to tip and add them up. So that is vector equations. Let's go down to geometric scalar multiplication. So remember, a scalar is a non-vector quantity, so it doesn't have direction, has size but no direction. Okay, now we can actually multiply vectors by scalars. So we can, let me highlight that for you. We can multiply vectors by scalars. Any value of k that's an element of the real number set. So it just makes it larger. Okay, so you just actually just magnifying it basically, or like, yeah, multiplying it or stretching it out so then it's longer and bigger magnitude. So if I had, for example, here, you know, my vector A, now remember it's bolded here for us. Obviously we can't do it bold with our handwriting, so we got to do a little squiggly line on top. But if I multiply it by 2, very straightforward, I just get 2A, so it's twice as long, okay, or A plus A. Same thing with if I multiply by 3, and then if I multiply by negative 3, or if I go negative A plus negative A plus negative A, I get negative 3A. Now, there's a little summary for you here about the size and the direction. It's pretty self-explanatory. Multiplying it by that number means it increases by that many times larger, and if it's negative, it's going in the opposite direction. So there's just a little summary in here for you as well about that. I'm just going to highlight it for you. Okay. Alright, so let's do this example. We've got this vector R and this vector S here. Construct geometrically 2R plus S. So let's say that's my R there. Okay, so 2R means I've got another one and it's going in the same direction, but it's going to be twice as long. So there's my 2R. S is going sort of this way, isn't it? So let's say that S is there. So 2R plus S is this resultant vector here. This is 2R plus S. Okay, that's all you've got to do. Let me just rewrite that because it's not very neat. 2R plus S. Okay, and then question B, R minus 3S. Oh, so we've got R's sort of going that way. Hang on. Yep, that's R. Now S is normally going like this, but I want minus 3S, so it's going to go this way, but it's going to be 3 times as long. So there's minus S there, minus S, minus S. Does that make sense? So that's minus 3S. So that means your resulting vector is going to be that one, isn't it? So that's r minus 3s. Okay. And then question 8, example 8 says sketch vectors P and Q if P equals 3Q. I'm just having a think. What does that want us to do? So if you have vector P, let's just say that's P. But if it's equal to 3Q, so that must mean Q must be something like that. And 3 of them fit, yeah, into P, I guess. I think that's all you have to do. I didn't draw that very well, but you get the idea. That's meant to be, you know, Q, and they're meant to be equivalent there. And then if you've got B, question B, P equals minus half PQ. So if I've got P, like this, say, it is the same as minus a half Q. So that means Q is twice as long. So I'm going to move it down here. So that means Q is twice as long. So let's just say that's it. That's negative and it's going that direction. So this is Q, I think. Yeah. Okay, well actually that'll be negative Q, won't it? Because Q's going the way, so that's negative Q. Because that is the same as negative half P. Yes, because what you could do is you could rearrange this. You could think of it as like, you could sort of multiply both sides by 2, so then you get 2P equals negative Q. So can you see there, if I do like say 2P, so if I added like another P there, that should be the same as negative Q. So actually I don't need that negative there. If I draw it the other way, so if I do Q's that way, so that means negative Q is this way, isn't it? Yeah, so 2P is equal to negative Q. There we go. Does that make sense? So I think it's just making sure that you understand direction and magnitude. So for that one, please have a go at the exercises. I'm pretty sure that's both of them covered. So have a go at exercise, we're up to 12B.3 and exercise 12B.4. I'm sorry, I haven't got the page numbers on me right now. You're just going to have to look them up, but please have a go at the questions.